Hello, everybody. Welcome to the 5th Spatial Data Science Symposium. And this is the opening session. I know that many of you are just joining, but we need to start on time. With me is Matt Matt Duckham for our first session. I want to very briefly walk you through how this is set up in case this is your first time joining. And then we're going to dive immediately into this first session, which is the interview. So first order of business, I would like to thank the team who make this possible, especially our program chairs that you see listed here. But this is an online event and in fact a distributed event. So there are 9 different local hubs. It took a lot of work for them to organize this. One is also here in Vienna with people dropping in and out. And of course also to host this platform, to manage the backstage area that we have, to make sure people are registered, to make sure people have the proper speakers link and so on. And the people doing all the magic in the background for you are Ivan Majic and Mina Karimi. We are going to thank them one more time in the last session. But keep in mind, they are the people who are making this all possible. And if you encounter technical issues, then just use the chat to reach out to them, or they're going to take you to the backstage area and making sure that we are all set up. So again, this is a distributed event. We are meeting here online, but there are many groups meeting together to recreate this feeling of not sitting alone at your screen. Thanks for those organizing those hubs. Maybe next time you do one as well. So a couple of numbers. The Spatial Data Science Symposium started in 2019. It originated from an expert meeting at UC Santa Barbara, and then people had the idea, let's take this forward, let's make this a bigger event. And then, as you all know, COVID hit, and Spatial Center had to move its activities online. So we hosted this online using this great RMIT platform, which at that time, and I believe still is, the best platform to recreate the feeling of being in a virtual conference. There are tables that you can use in the breaks. There's a backstage area where we can set everything up. Recording is really good. There's a Q&A session that you can use to, for instance, ask questions to Matt in a couple of minutes. Well, and then it just kept growing. And at the end, we had this idea of a distributed event. I think this is a really creative idea. Thanks for everybody making this happen. So there's the online part, but we don't want to be alone all the time. So there are 9 local hubs all over the globe, and they're listed on the webpage, and you can join them and sit together with between 5 and 20 people. Last time we went to one at McGill, and there were like 20 people, including us, which was really fun. So the number of people registered for this event keeps growing as I speak. Like 5 minutes ago, I made the last update. It's roughly 600. By the time I finished talking, we are at even more. But not all of them will be here during the entire time. People are going to sleep now. Others are yet to wake up. And then keep in mind, and this is maybe the most important part for you, that when you try to reach out to somebody here in the chat system, they may be sitting either alone, or they may be one of those hub computers, and whatever you type to them may be projected on the screen for everybody to see. So be careful who you approach. And then finally, keep in mind that, for instance, here at the Vienna hub, we are sitting here with several people, but not all of them are logged in, right? So there's more people listening to you than the people who are, for instance, live in a session, which right now it's the counter keeps growing. Is, for instance, 70 something people online already, I believe. So at the end, I believe we are going to have 300, 400, 450 people show up to at least one session, and I think that's great. And thank you so much for joining us. This is a community-driven event, so you are making the program. You know this if you have joined before. There are people who suggested sessions, and we are very thankful for that, and they're organizing these sessions. So make sure to give them some credit. Doing this online is always a little bit of a challenge. We have interviews, we have keynotes, we have tutorials, we have paper sessions. Most of them are organized by the community. We also have a Slack workspace if you would like to join, and the link is down there below, and maybe somebody else can also post them into the chat, which is easier for you guys to click on. So these are the hubs we have, as I said, all over the globe. Some of these hubs may be larger, some of them may be smaller, some of them will stay as they are for the next 2 days, and some of them will have people walk in and out. This is distributed across time zones, right? And again, next time, maybe join us also hosting one of those hubs. Okay, I do think that was all I really wanted to say. I don't want to eat into the time for the interview with Matt, because I'm sure that's the reason why you're all here. So welcome to our live interview, Matt. A couple of words before we start, and I have to read this off a rather small screen, so I hope I will do you justice. Matt Duckham is Director of Information in Society, the Information Society Enabling Impact Platform. I think we are going to learn a little bit more about this later. Professor in Geospatial Sciences at RMIT University, and also had a number of roles there already, like being the acting dean, associate dean of Geospatial Sciences, deputy head of the School of Mathematical and Geospatial Sciences, and so on and so forth. But many of you also know Matt from the fantastic textbook, and he has co-authored. There's a new edition. We are going to talk about this in a couple of minutes. And of course, he's also a fantastic citizen of our community and co-organizer of many events. And I just asked Matt about this backstage. When you are new to the COSIT conference, the Conference on Spatial Information Theory, you may notice that you type in COSIT and your browser gets redirected to a geosensor net web page. You may be thinking, what is this about? Well, this is Matt's working in the background. So Matt, thank you so much for joining us. I hope my brief description of your main duties or career is accurate, but diving more into what I really wanted to ask you, and there was the paper in the camera right there, is one of the key reasons why we are doing these interviews is that often we feel that we learn about people in paper-sized bites, right? And the paper is always the final product. Often it's too short because we had to cut it down to meet the page limit. And it's not providing a holistic perspective. Like, it's not telling you who is this person and why are they doing all this, right? So maybe tell us a little bit more about you as an academic and how you became who you are now.
Well, thank you, and thank you so much for the invitation to come and have this this chat. I think that the as you outlined there, this community initiative, there's a real kind of energy and buzz around SDSS. So I think it's well, certainly for me, a wonderful privilege to be invited along. So yeah, I was thinking about, well, what is what does kind of define me as an academic, and I guess we'll sort of dive into that in different ways. But I did have one story I thought I'd mention as where in terms of where I came from. I actually didn't study computing or GIS or anything like that as an undergraduate. I started off as an ecologist and a forester. I just wasn't very good at it, unfortunately. And in fact, I was so bad at it, we had my final year project. Part of it was looking at silvicultural systems, so forest management, and I was going out into the forest and taking these cores, like a corkscrew. You take the cores from the tree and do all sorts of measurements back in the lab on that. And my data was so bad that I couldn't even show a correlation between age and size. So I couldn't actually show that trees got bigger as they got older, which I took as a clear sign that maybe wasn't my calling. But I then wrote a little program, a computer program, actually just in BASIC, to simulate the forest systems that I should have been measuring but didn't get very good measurements of. And 25 years ago, that was unusual for someone doing a forestry degree. So they let me slip through because of that. But I took that as a clear indication that while I've always really appreciated that sort of natural sciences, experimental, lab-based, field-based training, actually I just wasn't very good at that, but hopefully I've been a bit better at the sort of computing side of it, which is where everything else since then kind of led me.
Well, that's very interesting. And this next hour is about you and not me, but I also need to share one brief story. I'm an ecologist by training. That was my first degree. And guess what I did? I did upper timberline ecology, where I took tree samples using the very, very same method. And you will not be surprised how I wasn't super good at that. And I wrote a computer program, but it was in Perl, not in Visual Basic. So I also got off that track. And I also think it's very, very fruitful part of my career, but I'm not taking any tree course now. Well, that was an interesting coincidence, very interesting. So you also just finished, or in fact, last year, the third edition of the textbooks, right? GIS Computing Perspective, absolutely fantastic textbook. And what are your highlights in preparing this third edition?
Well, certainly, simply writing it, I really enjoy that writing process. We do spend, you know, as researchers and academics, we spend a lot of time, obviously, writing to that sort of paper format, and we get very good at that, I think, and we get very practiced at it. But yeah, I find it a real privilege and joy to be able to take that sort of larger format of kind of working in a book and being able to maybe make it a little bit less rigorous, but a bit more sort of a story and a narrative. So I certainly I find just the process of writing, I've always really enjoyed that, and so that was very good. I finished, as you mentioned, I was really enjoyed spending some time as a head of department in geospatial sciences at RMIT, and that was quite all-consuming. It sort of takes yeah, occupied my mind and activities for the 5 years I was doing that. And so when I came to the end of it, it seemed like the perfect moment to go back to being able to work on the book. And I was invited on to join the second edition back in 2004 by Mike Warboys, who many of you may know. A professor, he's retired from GI science now, but still, you know, a wonderful person to work with. He invited me on in 2004 to join him as a co-author of the second edition. And so we were keen to sort of continue that. So one of the joys was working with Jane Sun, my friend and colleague, who came on as the third author for the third edition. And she really brought also another sort of a third heat, if you like, a different type of expertise. She's got very much a sort of geography and GIS background, and so brought also a lot of applications to things like, well, applications of machine learning and some of those sort of geographical perspectives as well, the geography perspectives. So that was also a kind of a big joy of writing it, was having another kind of third heat, another person on the team as well.
Well, I just took over the chair's role for our department here, so I feel your pain. I hope I will also finish a book once I'm done. Let's see about that. So, you know, there's a joke in computer science that when you go to a computer science conference, there's always somebody who's going to stand up, raise their hand, and says, I solved all these problems like 40 years ago, right? So we all would like to be the first to do something many years ago, but you actually have, right? So you have worked on decentralization and on privacy many, many years before most of us did. From your perspective, starting very early and being one of the pioneers of both, and looking at the current state of the art, where would you like to see both fields grow into the future? So decentralization and location privacy.
Well, it's well, kind of you to call me a sort of pioneer in those ones. I'm never quite sure that any of us are pioneers. I'm often struck that it sort of sometimes feels like there's no new ideas under the sun, and no idea is ever quite as new, or indeed quite as old as we think. I don't know if other researchers have this feeling, but very often when I am, you know, getting excited about a new topic, I sort of have what I think is amazing idea and go to bed feeling, oh, this is going to be amazing. And then you wake up the next day and see all the problems with it, or find the paper that someone else has already written on it. And so there's this sort of vacillation between these extremes, and often where you end up is sort of somewhere in the middle. It's never so amazing and revolutionary that nobody's done it before, but actually you end up finding that there are these kind of nice aspects to it. But yes, I really enjoyed working on both of those topics, particularly location privacy and sort of decentralized computing. Sort of from that sort of decentralization perspective, had this really, for me, I think, elegant problem of what happens when moving information has a geographic cost. You know, how does that change how you actually compute an answer if it's, you know, potentially you have to make that decision about, do I share the information, or is it, you know, is it better to make a decision locally with limited information because of the cost of moving that information around? And I think both topics were, for me, getting started with them was sort of a mixed success. For example, the decentralization, I really enjoyed them both. I really enjoyed working in that area. I was relatively successful with funding. I also I got a grant funded through the Australian Research Council, our sort of major science funding body, that you know, helped me work on that for a few years, and I got to write a book on it, and I felt that I made quite good progress on the actual content. But I don't think it ever really had good, or at least not yet, had much concrete application. The goal was for it to be working with the sensor networks and this idea of sort of smart dust. We'd all be taking a handful of sensors out of a bucket and sort of throwing them around the environment, and that would sort of allow us to sort of monitor at very fine detail. But of course, the technology didn't really go in that direction, and so that particular application, I think, is not, you know, I don't see much use at the moment for that. I still hope that those ideas will be sort of more useful, and you know, of course, there are other sort of aspects of decentralization which hopefully it'll be useful for, but I haven't seen I haven't really seen much application or sort of use of that technology or that sort of approach. And then from the other side, location privacy, that was in some ways was also quite successful for me, in the sense that it did seem to catch on. We had a couple of early papers, particularly on that sort of idea of what we called obfuscation, being able to deliberately degrade the quality of your location in order to protect that information. And that sort of idea seemed to we seem to just get, I guess, catch that at the right moment. But then oddly, actually, it was very unsuccessful from a funding perspective. I was completely unable to win any funding for it in Australia. So that also sort of pushed me away from that topic. You know, it just really wasn't something that the Australian kind of science and government was keen on funding in any way. So that was sort of another little mixed one. But yeah, it is great, particularly I think the location privacy I see here. You know, there's a kind of a renewed energy and all sorts of kind of new ideas and practical kind of applications as well. I think as I go through my career, I get also more interested and more focused on some of those practical applications. So it's really great to see that continuing to develop, and I'm glad if yes, things that I've done in the past have been helpful on that path.
I think that the privacy angle, I'm sad to hear that funding for this was difficult, but I'm not exactly surprised, right? I also did some privacy work, published a book in that area 2003. Nobody really seemed to care. But about the decentralization, that remains really one of the great mysteries for me. Like, it looks like we are good at decentralization, like distributing resources, for instance, in cloud computing, but there is no single successful example yet where it's distributed both in terms of the resources and the computing. And it's not for a lack of trying, like you said, this wonderful idea of smart DAS and, SDI. Then, of course, distributed ledgers. I mean, they are getting more successful now, but many of those that are really trust-free are still struggling, right? And then linked data, that was the next push for distributed data holding and distributed computing and federated queries. And at the end, if any of these products is successful, there's always a company or institution stepping in and saying, but it's less cost to do this at a centralized location with centralized computing, and then they're winning the game, so to speak. So I'm always a little bit puzzled about this, right?
Yeah. I guess I just hope that at some point it is more useful, but because certainly I think some of the ideas in that community, and a lot of them have also, this is more the sort of, there's nothing new under the sun. When I got into that, there's obviously a lot of work in the past in the computer science community, and so there's a lot to build on there as well. So I think there are some lovely ideas in that area. So yeah, I do certainly hope that it does find good applications as well.
So looking back at the last 5 years or maybe more of spatial data science, what are your most surprising or most insightful papers that you encountered or ideas?
Well, yeah, great, difficult question, actually, because as I think it's relatively rare that an idea, in the same way that I wake up in the morning and go, that idea I had wasn't actually as good as I thought it was. I think, in most, like most fields, we advance incrementally. So I don't think I come across things that are sort of necessarily surprising. But certainly if I think of the things where it's really opened up something new for me that I hadn't thought of. I think of topics like reproducibility. I think there's some fantastic work coming out here. I think I saw that Edzer Pebesma and maybe Daniel Nust and their collaborators, I think, were also maybe here as well. And I found that work really powerful. And to look back on all that we do, all of the work that we generate, and to know how difficult, how poor it is. I think we're, as a field, very guilty of this, as many other fields are, at being reproducible and being able to regenerate those results. So I find that a very powerful idea. And then maybe at the other, at a much less sort of technical end of things, coming and working in Australia from originally from the UK, where there isn't, there isn't any First Nations people, there isn't an Indigenous community. Coming to work in Australia, where there is at least 60,000 years of continuous society already here, is also another kind of remarkable privilege to be able to live and work on what's here Wurundjeri land. And I've had the privilege also of working with a number of Australian Indigenous scientists, researchers as well, and found that that change of perspective and being able to look at some of the things that we do in a very different way. And certainly some of the work on sort of indigeneity and GIS. So some of the work of people like Renee Sieber and Genevieve Reed, who are, I think, very good at sort of framing that very different ontological perspective, and that I found that really, quite powerful and surprising to look again at things that we already knew, and how the ways that we know them really shape what it is that we know.
Yeah, that's very intriguing and also a great step to the next question. But you mentioned something very interesting before, and we have many students here in the audience, so I think I want to dive a little bit deeper into that before we move on. You said that you have a great idea, then you wake up next morning and maybe the idea is not so great, or you start your literature search and then it all has been done like 20 or 30 or 40 years before. But I think there's also a really positive spin on that I'm also often trying to tell my students. If you want to know whether you had a really good idea, I always tell them, then check whether somebody else had this idea before, because only if there's a really good idea, other people had it before. If you have a great idea and nobody has that idea or even a similar idea, well, most likely your idea is not that great. People tried this, it didn't work, they didn't publish, right? So I think that if you are thinking this is very new and then there's a little bit of breadcrumbs here and there, I think it makes me just more excited that there's really something there. I wasn't, crazy or making this up after all.
Yes, yeah, completely agree. And yes, when you haven't, it's either that it's not that great an idea, or you just haven't found the literature where they have done something similar. But then when you find that there often is enough, like it is also original, or you find that you're naturally coming at the problem from a different direction, or something else has changed. So yeah, it's never as new or as old, I think, as we often think, but it still can be very valuable.
And then you also said that you are very interested in these different perspectives. You mentioned Renee Sieber there, right? And I think that's one of the great things that we add is geoinformatics or spatial data scientists, that many problems that don't seem to be spatial temporal really are, right? You mentioned like the different ontologies, so that people from different walks of life, from different regions, have different conceptualizations of the world, right? And I think this is very important now, coming again to the forefront of, for instance, large language models, and that they don't truly reflect this diversity of cultural richness and human knowledge. And it leads me to my next question here, namely, how do you feel you, but also our field in general, are contributing to addressing key social challenges or global challenges?
Yes, I think you're right. I think that we do have a special contribution that we can make that is partly from this, um, maybe boundary between sort of applications and rigor, between the enormous diversity of thought and backgrounds and intellectual traditions that end up coming to spatial data science, or sort of GI science. And yeah, I think that is a very sort of fruitful area. I know that when I started, I was much more attracted to, I hesitate to say theoretical, but it's kind of more abstract work, more mathematical work, and worked a lot also with sort of AI and computer scientists, spatial reasoning and computational geometry, which is really, really lovely to work with, really smart, capable people in those fields. And also the sort of work that often gets done is just done at a very high level. They're very good at what they do. When you go to a computational geometry conference, everybody is, if you like, sort of singing from the same song sheet. They all kind of understand the rules of what they're doing. They all have the same core training and the same core skills, and it leads to really kind of interesting and rapid advances. And there's it's a very efficient way of doing research. And I think often in, I was earlier in my career, I was a bit sort of less keen on the, if you like, the messiness of GI science, that we have people with a real range of different backgrounds and trainings. And so sometimes it feels less rigorous, I think, than, for example, a very mathematical topic like computational geometry. But actually, I think that's, as I kind of get older and maybe mellow or something, I think that's actually a key strength, that we are very good at talking across boundaries and being able to sort of pick up ideas from different places and translate them into new locations. And I think that also links, one of kind of, in terms of addressing global challenges, I think we're in a great place to be, that bridge to translating ideas into much more sort of practical, applied, and sort of impact focused frameworks. Often having sort of written grants with spatial reasoning and computational geometry people, often it's really quite difficult to write that sort of impact statement, because if you're want to, I don't know, a big step forward in computational geometry might be an algorithm that goes from n log n to n log log n, so, and there may be a huge amount of deep conceptual and theoretical work that goes into that, but in practice it's often quite difficult to make that connection to to who really cares, and how's that going to make a difference in the world. Whereas actually, I think there are arguments that often we find as a community extremely easy to make. We can see how better ways of creating, communicating, presenting, and analyzing spatial data actually really does have very practical and important applications, to the issues that we really face, like climate adaptation and social media, and responding to emergencies, or things that I'm sure many people here work on, all sorts of topics like that, with really important global challenges behind them.
Wow, that was sweet. I want to make this an interview, so I want to be the person on the other side of the mic, always adding something interesting to what you said, but I'm speechless. That was very insightful and very deep, and I can only agree, and I feel just the same. I'm no longer interested in small delta repetitive polishing work. I greatly appreciate this. It takes a lot of effort, it takes a lot of preciseness and smartness, but I love the messiness of our community. There are so many different topics and so many different perspectives on this. And also you clearly see, this is always the most fascinating thing for me, that where people are coming from really shapes their thinking, right? And in our community, I believe that this helps us talk across the boundaries of the physical sciences, the natural sciences, the social sciences, and so on.
Absolutely.
So maybe to add something that I finally can say something smart as well about, namely, you recently became interested in knowledge graphs, right? So that's a topic that I have been looking into also a little bit. Tell us a little bit about your motivation for looking into knowledge graphs.
Yes, and yeah, I am all about knowledge graphs, and indeed, thank you very much for some of your help, getting me up to speed a little bit, and I've really valued also talking with you about the work that you've done. I think certainly I started very much as a skeptic, both for sort of ontologies and the semantic web, and sort of knowledge graphs. I remember going to like a long time ago now, maybe 20 years ago, going to conferences where people were starting to talk about knowledge graphs, and thinking that's just never going to work. We've got so much invested, so much in relational databases. It'll never catch up. And then also from that sort of ontological side, watching early sort of GI science ontology work, and sort of not really being able to understand why it was any different from data modeling. It sort of seemed to be, to kind of reinventing the wheel. So certainly I think I'm late to this party, and I think there's probably a couple of things that probably have changed a bit in the past few years. I think certainly the technology has really got very good now. So you've put me on to, well, if we're allowed to, I don't know if we're allowed to advertise them, but GraphDB. But there are also a range of different graph databases now that really work at an extremely high level. And even though they're, I think, probably not yet quite up to relational databases in some sort of key spatial operations, and they don't have the sort of same range, given the amount of time that we've been working on them compared to the amount of time we've been building relational and object relational spatial databases. They're clearly superb bits of technology. I think also that the ontological side of it has gotten more advanced. It is something, as we were sort of talking about before, I think that's something we potentially do well in geospatial, because we're much more used to working across those boundaries. And I think that's what makes ontologies in geospatial much more challenging than in some areas. If you're I don't know, an electrical engineer or an oncologist, then you have a very particular way of viewing the world, and everybody you have to talk to typically has that a pretty close training and a pretty close set of ideas, which makes working with concepts, shared concepts, a lot easier. Whereas I think as a field, we deal with these very different concepts very frequently, which I think does make us kind of well adapted to help with advancing some of that ontology work. And I think that's certainly got a lot more mature as well. So that sort of combination I've really has really excited me in recent years. And maybe the third thing is that it's also, I believe, clearly very useful. I've been working with government organizations and sort of data custodians, also other organizations in a range of different areas. I've got another project just starting up with bushfire databases, and you keep coming across the same problems of not being able to clearly represent what it is that we're talking about. Spending an awful lot of time and effort linking up data and integrating data, downloading data and fiddling with it so that we can actually use it. So I can really, I'm very convinced by that. Having seen how badly needed some of this work is, just by such a wide range of organizations that currently don't really manage their data in a very efficient way.
So we have more than 100 people in this session now. So folks, please keep in mind you can use the 2 Q&A speech bubbles to also enter your questions, and then later we can pick from them. So just that you know. Yeah, very interesting. So one of the things, going back to this ontology discussion, that I think is very interesting is that in early work on ontology, aside of the fact that the technologies weren't maybe that mature, it was basically the old ideas that you could standardize meaning, right? That you would have a few people sitting in a room and they would tell the rest of the world how the world is structured, right? And then a couple of years later, and that got me really hooked, we finally arrived at this idea of that ontologies capture local agreements, local views that depend on culture, depend on time, right? Knowledge evolves or devolves depending on who's elected, right? And that had me really interested in ontology research. So how can you align different views? How can you deal with conflicting statements? And in the early days of formal knowledge representation, especially those with mostly, declarative knowledge representation based on axiomatizations, that was really difficult. But then many people started to work on like measures of similarity to align different domain views, for instance, in the area of forest and so on. And I think that we were very fast in this work. Think about, David Mark, Max Egenhofer, Werner Kuhn, Andrew Frank, Helco Kleelis, all these, fantastic folks who did this, 26 years ago, right? And I think they were early because we are so trained as bridge builders and as geographers and as spatial scientists and as geographic information scientists to understand that concepts are created in the minds of humans in the communities. They are a way to communicate, to find a common language, to quote Harari. And there's no one single one to beat them all, so to speak. And we need to find ways to align them to make our data more interoperable, right? To this day, I often find myself having to explain to other people, especially in the physical sciences, that there's no, God-given, so to speak, definition of forests, right? Or the fact that the definition of planets changed many, many times throughout history, right? Shows that these are human constructs. And it's interesting to see why people have different views, why communities emerge with different perspectives, right? And that goes through so many different areas. Now I'm working a lot with conflict data. I'm trying to work a lot with conflict data. And why this is deeply depressing, on the other hand, it shows that almost nothing is contradiction free, right? There are multiple perspectives of the same phenomena. And I think going back to the wonderful things that you said, this is our core strength, right, as a community. And of course, the knowledge graphs, as you said, they bring in this this wonderful distributed paradigm. You know, we started at the beginning of our interview with that. So I also think that these are very, very interesting technologies, further worth exploring. Right? So, as a GI scientist or spatial data scientist, how can we communicate most effectively both downstream to the domain areas and upstream to disciplines that are more abstract, right? If you're a student, you often think to yourself, geographic information science or spatial data science is a bridge building discipline, right? We often paint this so nicely, right? There's the domain bridge and there's the computing bridge, and we are the nice bridge builders. But these days you see a lot of folks from the domain scientists, like biology, ecology, who are damn good data scientists. Maybe they don't need us. And then you see computer scientists who say, I'm very interested in space-time or in disaster management. So where do you see our unique role these days?
Yeah, and it's a really important question, isn't it? Because we do constantly have to be sort of asking ourselves, and people are asking us, so what is it that you do? What's the value that you add? I did spend some time thinking about this a few years ago, and I've given you my answer, and interested to might be interested to see if other people agree with it or disagree with it, because it seems so far I think it sort of seems to work. And really, for me, there's 5 things that in different combinations are our sort of unique contribution, our unique value. There, first, the spatial structure. I think we get that spatial data is not like other data, not like a library database or a bank database. So things like autocorrelation, and if you're a computer scientist, you might start out with well, I'm just going to assume space is random in this, location could be random in this Euclidean plane. Well, as spatial people, we kind of know that never happens. That's not a good starting point. So I think we're quite sophisticated with spatial structure. I think we actually know about uncertainty and kind of imprecision, inaccuracy, vagueness, and ambiguity, these sorts of things. Again, I think they're tricky concepts. I don't think we always get them right, but I think we do have quite a high level of sophistication in that area. My third one is around dynamism, that the world is changing, our data is often not changing, but really should be. And again, that's one where, even though I think the tools that we use and the concepts that we use are often not necessarily that sophisticated yet, from that sort of perspective of dynamism, of spatial temporal information of the world changing. Actually, I think we do as a community have quite sophisticated ideas. It reminds me of, I know, something like economics, where sometimes an economist gets criticized for assuming that humans are rational, and we sort of go, well, they're not rational, they do all these irrational things. But actually, economists are very, very aware of those assumptions, and so if you like, the simplification is actually a reflection of the sophistication of the sort of ideas behind it. And then the other two are in cognition. So I think we've got a long history of working at that boundary with spatial cognition, with how humans think about space, and the sort of mental constructs and shortcuts and distortions that go on. And then I think the sort of design side of things, the cartography and visualization. So those 5 areas, for me, I think most of the sort of what I would think of as maybe that core GI science literature typically works with at least a couple of those, sometimes more than a couple. And you know, typically, I think, you know, it would be interesting to know whether the people listening to this identify with one of those areas. I think there are some areas like, I know, computation. That's something I've worked a lot in, which I don't put in that basket. You know, I think you know, there's no reason why we can't be computational. That's certainly something I've worked a lot in, but I wouldn't sort of think of us as the, you know, that's not necessarily where we add our value, because you know, when you work a lot with computer scientists, they're often do have quite more sophisticated techniques and ideas around that. So for me, it's those sort of 5 things in different combinations that I see as really being a kind of our value, and the bits where we're at our best in bridging between kind of applications that need, let's say, to, you know, present data in a way that is compelling and helps decision making, but they have to deal with sort of, you know, low-level computational problems. We have to sort of be able to bridge between the applications and the technology.
That was a wonderful answer. You are incredibly good at structuring this. If this wouldn't be live, I would accusing you of being ChatGPT. I'm very, very impressed. But to add one thing where maybe you haven't addressed this so explicitly, and I would really be interested in your opinion, is that we also provide back to our upstream communities, right? And I often say that GeoAI, for instance, is not AI for geo, right? AI for geo meaning using AI techniques for geo applications. It's also that a lot of stuff that we develop in our community of spatial data science or geographic information science that is then used upstream, right, by more general applications in AI. And I think that strengthening this is really important without trying to develop, like, for instance, computer science envy or physics envy or philosophy envy, right? So for instance, one thing that I keep coming back to is that many people in the core AI literature now, also especially in industry, look at biases in AI data. We have a very long history, as you said, dealing with messy data, with uncertainty, with biased data. And then if you read their papers, they are using terms originating in our community, like the modifiable area unit problem, for instance, right? And ways they think about them, I think, is then sometimes very surprising, because they believe diversity, geographically speaking, would be the count of regions, of countries, so to speak, where the data comes from, totally ignoring that these countries are not homogeneous, for instance, or that populations differ. Or to give you one example that, you know, that was so shocking to me, because for us, it's crystal clear, and then you sit across the smartest people on the planet and they don't get it, right? So for instance, if people report about the sustainability of Gen AI, they report this by the average power consumption of a citizen across the world. But this number is totally meaningless. This person doesn't exist. And this person's power consumption looks relatively high because some countries like the United States consume so much more energy on average. But then if you look at the actual distribution, then, you know, almost the entire world population consumes less than this average person. So if you are trying to sell how eco-friendly Gen AI is, then absolutely you're going to use your average power consumer, and it looks like it's only a couple of thousand. And then you say, but what about the real people on the ground? And then suddenly it's millions and millions of them, right? So I do think that we can really contribute something upstream, right?
Yeah, nice.
So staying with this topic of AI and Gen AI for a couple of more minutes, this is really shaping universities so quickly now, right? You are also very versed with editing, as a role of editing papers, right? And I'm sure you already saw papers that are very clearly, you know, co-authored by AI. And as an educator, you probably see this, maybe even as a mentor. It has ups and downs, right? Can you think about where this is going in the next couple of years?
Yes, and actually, in my current role in my university, I've also been leading a number of initiatives internally to sort of help researchers at RMIT kind of adapt and deal with, you know, research integrity in this new environment. I think in some ways it's another one where everything changes and nothing really changes. I think from that sort of research integrity point of view, the same rules apply. And okay, the technology's moved on. It's, for example, made it a lot easier to falsify data, but falsified data was always a problem. It might have made it a lot easier to author something that you haven't really authored, but we've had authorship issues for a long while as well. So and that's absolutely not unique to this field. So yeah, I think for me it actually underlines helps underline the value of, or where the value lies in things that we do, because fundamentally, if the machine can do it, it isn't very smart thing to do. Like the machines are pretty dumb, so anything that a machine can do, we really shouldn't be spending our time doing it. We should be spending our time doing the things that the machines can't do, and there's an awful lot of those. So I actually, in not just in research but also in sort of teaching as well, it's obviously a challenge because a massive challenge for all the reasons that I think everybody here knows, but I think it actually does then reflect that what we were testing in our, if it's an assessment that someone can go away and put into ChatGPT and get the answer, probably wasn't actually a very good assessment. It probably wasn't assessing the things that we really wanted to be assessing in the first place.
Fantastic. So there's a couple of questions from the audience. I just wanted to move one question to the screen, but no, I think I can still do this. Now it's gone again. Well, I'm going to read it out loud, but I think folks in the backstage, you could just move the question onto the main screen. Exactly. Is it working? Yes, it is working. Perfect. Thank you so much. So, well, Ray is admiring your book as so many of us do. So what do you think are the key skills that our community is still lacking in their education?
It's a good question. Well, thanks for the question, and thanks for the kind words as well. So, well, I'm going to give maybe two different bits to it. I often think that there certainly are. Well, maybe the best way of one thing I will say is that programming is ever so useful, and I think it's intellectually a really good skill as well. So I must admit, I do encourage everybody that I work with to get good at building things with their sort of coding, or these days with the help of Copilot or ChatGPT to write the code, but you've still got to do the sort of thinking behind it. So I think there are certainly some skills like that. If I'm sort of thinking what would I like everybody to have. I do, though, think I guess I'm moving a little away over time to specialized GIS education. Maybe it is things like the ability with large language models to generate huge amounts of text. It really underlines some of the sort of fundamental critical thinking skills. And so, the fact that I didn't really do any GIS in my undergraduate actually has never, I think, been a barrier. I really ended up with quite a general science degree, and that's been incredibly valuable. So I suppose that, I think there are certainly skills as researchers and some core concepts that kind of everybody, a bit of sophistication that everybody needs to know, a bit like you were saying. Sometimes in those sort of upstream areas, it really highlights that there are some ideas that we have as a community, some sophistication that we have as a community that is really valuable. But I think it's actually those core skills that more and more I sort of, in terms of the sort of educational program, I'm less convinced by the highly specialized sort of GIS education programs, and more by more generalized, critical thinking, being able to kind of build things and being able to connect ideas a bit more flexibly.
Wonderful. I really couldn't agree more, especially also what you said on programming. The fact is not the programming as such, it's taking a problem from the real world and learning how to express this in the way of how computers structure their operation. I absolutely agree. So bringing the question on stage worked very well. Now we are trying to pull off the next stunt and bring somebody on stage, namely maybe Bernd, to ask the next question. Bernd, are you with us?
Yes, do you hear me?
Absolutely, yes.
Hi, everybody. Very good to see you, Matt, again.
Hey, Bernd.
Thanks, Jan, for the invitation. So, thanks for the interview. It was very enlightening. So, what you were saying is there was a very broad take on things, right? Like you talked about computation and geometry, and that people in there have their own, like, I don't know, disciplinary, if you wish, procedures and thinking, right? Then you talked about algorithm design, cartography, visualization, interaction design, ontologies, GUI, and so on. Now, recently I moved to a university which has interdisciplinary in its name. And yesterday night we sat together for designing our first master's program. It was a discussion until midnight or so. And my question to you would be, which funding category do we belong to, right? Because we always say, like, for other people, like in my university, let's design projects in hydrology or computer science or whatever Bernd is doing. So, and then I need to explain, like, in very long terms what I'm doing. So, what would your take be? Like, can you describe to me who we are?
Oh, I'm not sure I can describe who you are, but I think I've really struck that by your move and the general move for these much more interdisciplinary kind of institutions and programs and ways of looking at the world. And yeah, I do find that extremely valuable. I mean, I guess I guess I do think it's still very useful to be able for as an individual researcher to be able to maybe point to one or two sort of disciplines that you really feel that you are expert in, that you're sort of coming from a position of deep expertise and strength in those areas. But then the key thing is to be able to learn those skills, to be able to collaborate with other people who have different intellectual frameworks and different approaches to problems. And I think incredibly sort of interesting and impactful work comes out of that sort of thing. So maybe that is part of like if we had to come up with a definition, it is that perhaps that ability to have strength in let's say one or two of those areas, but also to be able to work across the boundaries to the other areas and be sort of aware of the other concepts in those related areas. Not a very good answer, I'm afraid.
I thought it was fantastic. We only have 1 minute left and we have to stay on time. So I want to close with the following question. And by the way, I hope you guys all appreciate Matt answering questions instead of playing Ave Maria. I guess that's also a difference between science and other fields, if you hear me. So sometimes in the future, like let's say 5 years from now, a student will be sitting in front of YouTube playing this on twice the speed and then deciding to move over to the last 5 minutes of this interview. The single take-home message that you hope the student will hear, what is that?
We still work in a boys' club. Academia is still a giant boys' club, and certainly, I suspect you've experienced exactly the same thing. Being white and male and speaking English has been a massive part of my success, or if you like, or my career has been massively supported by that. And we're making progress. I think certainly. Working in a sort of public university in Australia, publicly funded university is a good environment because it's a clear priority, where things are changing. But boy, we've still got a long way to go. And for me, it really comes to the core of what we all do, like as researchers, as academics. If we can't get this right, if we can't represent the communities that we're part of, then I don't think we deserve that public funding. So yeah, that's the key thing for me. Is leaving aside all the kind of great ideas. It's a massive privilege, but it's an unearned privilege, and so I'd really like everybody to leave their field in a better state from the point of view of well, particularly diversity and inclusion, but particularly gender equity. It's has to be the top of our priorities.
Absolutely, and no lame excuses, right? You will see, for instance, on the weekend I'm organizing a GRI meeting, and there's gender balance in that meeting, and we took care of that, and it's doable. So things take time and work, but there's no lame excuses. Well, fantastic. That was so insightful. Luckily, we got this recorded. I'm going to play this to all my students. And I thought it was absolutely wonderful. I hope you enjoyed it as well. We are going to take a roughly 15 minutes, 12 minutes break by now, and then we are moving on to another fantastic part, namely our first keynote speaker. So thank you so much. You can't hear them clapping, but they all do, the 103 people here right now. Thank you so much, Matt.
Thank you so much. It was an absolute pleasure.
Bye-bye.
Bye-bye.
We can close the session now.